Hi everyone. In this video, we'll be taking a look at some considerations to make when designing or buying a computer for use in audio applications. I spent a number of years working as a technical consultant for various film composers and studios, which involved speccing out rigs, building custom computers, and lots of troubleshooting. In the past, designing a computer for audio was quite a challenge, which required careful part selection and optimizing things in the operating system, but nowadays things have gotten a lot simpler, and pretty much any compatible set of parts will work well for audio. The first factor to consider is the case. While it might not seem that important, it affects the cooling, and as a result, the amount of noise that the computer makes. You want something that can efficiently move air through the case without requiring too many fans. Larger fans are generally quieter than smaller fans. You should also try to find something that has filters to keep the dust out. Some people prefer to go with a case that has a glass side so you can see inside, but I prefer not to do so, as I find that tends to be quieter, especially if there's a dampening material lining the inside of the case. As far as fans go, I recommend the Noctua fans using the low noise adapters that come with them. These adapters make the fans run slower and so are quieter. You'll just want to make sure that they're pushing enough air through the case to keep things cool, so you'll want to run some stress tests and make sure that the temperatures are okay. Having the ability to change the number of fans in the case gives you the flexibility to experiment and find the best balance between noise and amount of cooling. For the CPU cooler, I also recommend going with Noctua and trying to find the one that has the biggest heatsink and is compatible with the system you're using. Again, you'll want to use the low noise adapter to keep the fans spinning slower as long as you're getting enough cooling. As far as hard drives go, you'll definitely want to go with SSDs, again to keep the noise down. For extra storage, I'd recommend having a NAS in another room. If you're using a lot of samples, such as for film scoring uses, the number of drives that you use is an important consideration. Each SSD can only handle so much throughput. That's not necessarily the transfer rate, but more based on the input and output operations per second. If you're doing things like large orchestral mockups, I'd recommend having at least 2 separate SSDs for your samples. In some cases that might not be enough, and you might need to spread things out over 4 SSDs. Balancing your sample libraries between the SSDs is an important consideration, and that would be based on exactly the material that you're writing. An example might be to separate strings, brass, woodwinds, and percussions all onto separate drives. Many samplers such as Contact give you the ability to adjust the preload buffer. This balances how much of the sample is loaded into memory and how much of it is streamed off of the hard drive. If you find that your hard drive can't keep up with your streaming needs, then you'll want to adjust that to load more into memory. The downside is that you'll need enough memory to load that all in. Moving on to memory, the speed and other related factors don't matter much for uses in audio. Aside from having enough memory to run your operating system, DAW, and any other programs you have running, the amount of memory that you need is primarily related to the amount of samples you want to run and certain plugins. Most plugins don't need much memory, but ones such as convolution reverbs and any other FIR-based processing will generally require some memory. 16 gigs is a good starting point, and 32 will pretty much guarantee that you never run into any limitations, but if you are a film composer and running lots of samples, then you might need 64 or even 128 gigs. Moving on to the motherboard, your choice will mainly be limited by your choice of CPU and the case. The motherboard is really the only part of the computer where you might have some incompatibility for audio use. Certain motherboards can just have some unpredictable behavior, which will lead to dropouts and things like that, which you'll never really be able to fix. So there is a small chance that you'll buy a motherboard, it won't work well, and you'll have to switch it out for something else. I recommend going for ones that are more bare bones without too many gaming features or anything like that. These will generally be the cheapest ones around. You also want to make sure that it has all the I/O and expandability you might want. This includes a number of USB connections, PCIe slots, memory slots, and spots for M.2 hard drives. As far as the power supply goes, you'll want to get something where the fan won't be running. This generally means getting one that has a much higher wattage than what you actually need. Many manufacturers will give you a graph showing the power usage versus the fan speed, so you'll want to make sure that you stay below where the fan turns on. Again, this just ensures that your computer will be nice and quiet and doesn't have to be in a separate room. I also recommend getting something that's modular, which is a little more expensive, but will keep your computer nice and clean. The most important part of designing a computer for audio use is the processor. The 2 important factors to look at are the number of cores and the speed. Different applications require a different balance of these two factors. In most DAWs, a single track can only be run on one thread. This means that if you have a lot of plugins on one track, they'll all be running on the same core, which makes sense since you can't parallelize the processing for each plugin. It has to happen in a serial fashion with the output of one plugin going into the input of the next. This means if your work involves putting a lot of plugins on a couple of tracks, you'll want the highest possible core speed. If your processor isn't fast enough, you might find that if you run, say, 5 plugins on one track, your computer will struggle, but if you run only 4 plugins on that track and it runs fine, you can duplicate that track many times and it will run without any problems. This is because every time you duplicate it, that processing load gets put onto a different core. Your limitation is only the speed of each single core. If your work involves not much processing on each track, but just a lot of tracks, that's where you might want a lot of cores instead of a faster speed. My main orchestration template, for example, has over 1,000 tracks in it, but they all only require a small amount of processing, so it can be distributed among the cores. This leads to an interesting limitation of Apple Silicon for uses in audio. While they have many different processor models like the M1, M1 Pro, M1 Ultra, they actually all run at the same speed. The only thing that you get is more cores. If your work requires high core speeds, and you run into a limitation with the M1, this means even if you upgrade to the M1 Ultra, you might still have the same limitation. Unfortunately, the Apple Silicon runs quite a bit slower than Intel and AMD processors nowadays. Another factor to consider relating to the processor is overclocking. While this will give you more performance, the trade-off you're making is it'll need more cooling, and so you'll probably have more noise from your computer. The last aspect to consider is the GPU. Many CPUs have an integrated GPU nowadays, but I would recommend still using a discrete GPU just to offload some of the processing from the CPU and be able to prioritize that for audio. As with the power supply, you'll want to make sure the GPU's fans stay off unless you're running a graphics-intensive process like gaming or video editing. When running only your audio applications, you'll want to make sure the GPU fans stay off. Relating to the computer design is the choice of interface to use in your system. The stability of the drivers and the buffer you're using both affect how much processing your computer is able to handle. Faster processor speeds will mean you can run your system at a lower buffer, but at the same time, if the motherboard has any weird behavior, that can get in the way. Hopefully this overview helps you get started in speccing out a system. If you're a film composer, you'll want a high core count, but the speed doesn't have to be too high. You'll also want a large amount of memory, such as 64 gigs or 128 gigs. If you do a lot of mixing, you'll want a good balance between the number of cores and the speeds, so generally at least 8 hyper-threaded cores running at over 4 GHz. Memory isn't too important, so 32 gigs would be more than enough. If you're a mastering engineer, this is where you'll want very high core speed, and core count doesn't really matter. 4 cores should be more than enough. You also want to dial in the overclocking to get as close to 5 GHz as possible. This will let you run the most plugins on a single track, which can be a problem for intensive mastering plugins and higher sample rates. Again, the amount of memory here doesn't matter much, and even 16 gigs would probably be enough if all you're doing is mastering. I hope this video helps. Feel free to get in touch and send over any questions.